Today's job is to place a bunch of additional CO1 reference data onto an already quite large reference phylogeny of Lepidoptera. Now I've gone through the process of making a large phylogeny which is all in which the basal relationships are all fixed, and I've added to that everything that can be done strictly placed into that framework. There's a bunch more which cannot be fit directly into that framework, but there's a lot more data which can be added. Now this component of the data is quite difficult to get. It's quite difficult to maintain the phylogenetic quality of this. So I've reduced it as much as possible to only that which is really valuable and informative and has good prospects for being placed. Now this reference phylogeny is being used in a specific project for profiling a load of caterpillar data, plot data. So first thing I've done is I've limited this additional component to only those references which are pretty similar to the plot data. That's one thing. The other thing, I've run the XML evolutionary placement and also just identify those which have a reasonable placement likelihood. So with those two filtering steps, I'm down to, so it's just 327 reference CO1 which I will add to this already large phylogeny of about 6,600 species, or a bit more, and I'll take it up to about a 7,000 species reference phylogeny. Now I've taken a rather conservative approach and only added a small amount relative, and even that, it's going to be going through a bunch of load of source trees available which might have some additional information for placing those. So these are the large set of source trees using the soft relational constraints output. I've just run XML and this is now finished. So these are, as I've said, I've added additional reference data to an existing reference tree, so you can't really tell which ones I've added. So I want to visualize that. Now I have a file. These are the 327 extra things that I've placed on. So I think I'll just write a bit of code to read this list and then modify the nuke string with an extra string which I can search for in the tree viewer to hide, so I can highlight these extra things which have been placed, so then can inspect do they look reasonable. A rough indicator of the reasonable placement is simply the branch length. If it's on a very large branch, then it's probably no good. But so I'll write a bit of code to highlight these. Okay, so just echo and a string, writing this into a temporary Perl script. Open this list here and add each binomial into an array, open the tree file, which has just been output by XML, store the tree in this object, and then just loop through each ID, and in the tree do string replacement, search for the ID and replace with the ID, adding the string placed. Then we'll just pipe this into a new file, and then we should be able to find all our the subset now should be searchable. So again, these are the non-highlighted one. These are the original reference tree, and now we've applied. So the original was all fixed constraints, and this additional step is for soft constraints, and these soft constraints are a lot less reliable to place, which is why I want to inspect them, which we can do now. Just have a and see if these look reasonable. And already I'm not really sure about these. So we have here a monophyletic group of the genus Graphylita, and one of these soft placed species has gone right in the middle of this. And this looks here, so here is something quite clearly suspicious. We have species from different genera with a almost identical sequence, and then we have congeners which are placed in quite different locations. We have a bunch of stuff from very different genera, all stuck in the same place. So after just an inspection, I'm really not happy with this. Same thing again. So I'll go back to the drawing board with this. It's good thing I checked. I have been through this process with the synthesis phylogeny of bees, and what was necessary was you have to find source tree information for everything that you place, which I haven't actually, which is a process I haven't done for this Lepidoptera dataset yet. And that did work with the bee synthesis phylogeny, so I think it's necessary. It will be necessary to do the same thing. So anything on the soft constraints needs to be covered with source trees. So after an inspection, I'm going to have to. There's a lot more work to do. I'll have to find source trees to cover anything. So ideally, a source tree would include the members to be placed and members of the existing reference tree, and they should provide the information to place them correctly. So I will try and find a source tree of a published phylogeny of Rejectaria genus, for example. So that will be the next job to do. But for now, job done.